Okay, in this section, we're going to be talking about finding the equation of a line in different situations. Reminder from previous sections that when a line is in the form f of x or y is equal to mx plus b, this form is what's called slope-intercept form, to where the number being multiplied by x, so the number in front of x is your slope, and the number being added or subtracted is your y-intercept. Such as if a line is written in the form y equals 2/3 x minus 6, we know that this line is in slope-intercept form. And we can identify its slope really easily, which is 2/3. And we can identify its y-intercept fairly easy as well, which is -6. And we can look to graph this to where our line is going to cross the y-axis at 1, 2, 3, 4, 5 at -6. And for every 2 that rises, it's going to run 3. So we can very easily draw a picture of this line. Now what we're going to be doing in this section of the chapter is what if we were asked to work it backwards. First off, what if we were given the line? How could we go from the line back to this? Well, pretty easy. Step number 1, find your y-intercept. Step number 2, find your slope, your rise and run. Well, here we have a slope of 2/3 and a y-intercept of -6. So we see that we can go from here back to here fairly easily. The first set of problems are going to look like this. They're going to ask you to find the equation of a line, and they're actually going to give you a slope and a y-intercept. So we know, again, that the equation of a line will always look like this when it's in slope-intercept form, y equals mx plus b. And if we're given that we have a slope of 3, we know that we simply place it where the m is. And we have a y-intercept of -5, so that simply goes where the b is at. So the equation of a line with a slope of 3 and a y-intercept of 5 would be y equals 3x. Don't forget to put your x. And -5 is tacked on the end. That line has a slope of 3 and a y-intercept of -5. Next up, let's look at this. Given a graph, we can also very easily find the equation of a line. Again, the main 2 things that we need when finding the equation of a line is a slope. And we can find that, first off, let's find some lattice points. Looks like it crosses here, looks like it crosses here. We identify our slope as being a rise and run. Here, for every 3 that my line rises, looks like it goes over 2. So therefore, we have a slope of 3/2. Rises 3 and runs 2. And we have a y-intercept of 0, 2. So therefore, if we're asked to find the equation line, the equation line will always look like this. Y equals the slope times x plus or minus the y-intercept. So the equation of this line will be y equals 3/2 x plus 2. Okay, the next set of problems are a little bit more difficult. What we're going to be asked to do here is we're given that a line has a slope of -5 and it passes through the point -4, 2. And we want to know the equation of that line. Well, to find the equation of a line, again, we need 2 pieces of information. We need a slope and we need a y-intercept. In order to get it in y equals mx plus b form, we need a slope, we need a y-intercept. Here we only have a slope. So I'm going to talk about 3 different ways that you can actually work these problems. And the first way probably being the worst way. But if you choose to use this method, it is possible. Because I want you to get a picture of what we're actually looking for here. We have a line that passes through the point -4, +2. And the same line has a slope of -5, or if you want to write it as -5/1. For every 5 that we go down, for every 5 that we go down, 1, 2, 3, 4, 5, we're going to run 1. So we go down 5 and we run 1. And we could continue the same pattern, and we could actually find the y-intercept, but unfortunately, it looks like we're going to run out of graph paper here. But we could go down 5 over 1, down 5, down 5 over 1, down 5 over 1, and do it one more time, and we could actually see what the y-intercept is going to be. Let me use a different sheet of graph paper here since this one's not big enough, and we'll try to see where this is going to cross. Okay, I've switched graph paper here, and what I'm going to do, I'm going to put my origin, my 0, 0 here, and try to graph this thing. So I'm passing through the point -4, +2. So 1, 2, 3, 4, 2. Here's my point -4, +2. A rise and run of 1, 2, 3, 4, -5/1. 1, 2, 3, 4, -5/1. A couple more times, 1, 2, 3, 4, 5 over 1. And I believe I'll have to do it again, 1, 2, 3, 4, 5, and over 1. So it looks like, again, here's my y-axis. And it looks like I'm going to cross the y-axis. If I drew this line, it would cross the y-axis right here. And we can count down, since I did number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have a y-intercept of negative 18. And now that we have a slope and we have a y-intercept, we have an equation. The equation of this line would be y equals negative 5x, since negative 5 is the slope, minus 18, since negative 18 is the y-intercept. Okay, the next method of working this problem, we're going to introduce a new formula to you. You might want to put this formula into your notes. It's called point-slope formula. Point-slope is a method or a formula that we can simply plug a point and a slope into in order to get the equation. Point slope looks like this. Y minus y1 equals m, or the slope, times x minus x1. And what we're going to do, we're going to plug in our point into x1, y1. The x value of your point going into x1, the y value of your point going into y1. And we're going to plug our m, or our slope, in for this m value. So as we plug these in, I have y minus y1, which is 2, equals m, which is negative 5, times x minus x1, which is negative 4. Make sure both of these negative values are important. This minus is built into our formula. This minus is here because our 4 is actually negative. Anytime you have two negatives next to each other or two minuses next to each other, we can change it to a plus. And we simply clean it up. First step, distributive property. Let's remove parentheses. You now have y minus 2 equals negative 5 times x, and negative 5 times positive 4 is a negative 20. Last step, in order to get rid of a minus 2, we're going to combine like terms here. We're going to move it across by doing plus 2. We now have y equals negative 5x and a negative 5x minus 18, which is the exact same answer we got the other way. Okay, the third and final way to find the equation of a line, we can actually use slope-intercept in order to obtain this equation. We have a slope and we have a point. So what we can actually do is we're looking for a y-intercept. We're looking for our b here. So we could actually take this same xy point and our m and plug it into slope-intercept form as well. Our y value is 2. Our m value is negative 5. Our x value is negative 4. And we are unsure about our b value. Again, we're trying to obtain our y-intercept or our b value. So what we're going to do is we're going to solve this equation. The first step, negative 5 times negative 4 can be multiplied to give us a 20. And that should be plus b there. And we're looking for what b is equal to. So let's solve this little basic one-step equation by moving 20 from the right side to the left side by subtracting 20. 2 minus 20 is negative 18. So that tells us that b is negative 18. And since I know b is negative 18 and I also know what m is, I know that my equation is y equals m x plus b. And we get the exact same answer. Okay, I want to work one more problem, the same type problem, to where we have a slope of 2/3 here and a y-intercept of have a slope here of 2/3 and a point 1/4 that the line passes through, and that is not a y-intercept because we know y-intercepts look like of the form 0, some y value. So 1/4 is not a y-intercept; it is simply a point on the line. Again, I'm not going to use the graphing method here, but that is another option. What I'm actually going to use is point slope, and then I'll work it with slope-intercept form as well. Y minus y1 equals xm times x minus x1. To where I have a y1 value, again, remember this is xy, I have a y1 value of 4, I have a slope of 2/3, and I have an x1 value of 1. Distributive property, y minus 4 equals 2/3 times x and minus 1. Gives you 2/3 x. 2/3 times negative 1 is negative 2/3. In order to move 4 over, I'm going to have to do plus 4. Cancels out. And the way that I'm going to add those, I'm going to put 4 over 1. I'm going to find a common denominator there. I've got a negative. I'll come over here to the side and do a side note here. Negative 2/3 plus 4 over 1. Common denominator here would be 3. So now I have negative 2/3 plus, multiply top and bottom by 3 to obtain that common denominator, and I get 12 over 3. So a negative 2 plus 12 would give me a 10 over 3. So that gives me an equation of y equals 2/3 x plus 10/3. Again, we have a second way of working this. We can always find an equation with slope-intercept form. The way that we do that, since we have a slope and we have a point, we're first going to try to obtain a y-intercept because that's the only other piece that we need. We do so by plugging in y, which is 4. We plug in m, which is 2/3. We plug in x, which is 1. And we're looking for a b. So I have 4 equals 2/3 times 1 does give me 2/3 plus b. When I move 2/3 over, I'm going to do so by subtracting 2/3. So I've got 4 wholes minus 2/3. Common denominator, which would be 3, so I'm going to multiply top and bottom by 3 to obtain 12/3 minus 2/3, which is, again, 10/3, which is the same answer we got on the previous way as well. So that gives me an equation of y equals m, which is 2/3, x, and then plus your b, which is 10/3. And we obtain the exact same answer the other way as well. Okay, the next type problem we're going to work is sometimes given 2 points, you will be asked to find the equation of line. So here, that's what we have. We have 2 points. And one way of working it, and again, probably the worst way that we possibly could work it, but I do want to give you a picture of what we're actually trying to find here. We're looking for the line that passes through the point negative 2, 4, and 4, negative 8. So we're looking for the line that passes through those 2 points. So one way of working it is we could plot the 2 points. We could connect the 2 points with a line, and we could simply see where it's going to cross the y-axis. Because, again, in order to find an equation, we need 2 things. We need a slope, and we need a y-intercept. So first off, let's look for our slope. And now that we have the points or we have the graph, we could either do rise over run using our graph, or we could do the whole y2 minus y1 over x2 minus x1. Since we have the graph, I'm simply going to count. From positive 4 down to negative 8, that is a rise of negative 12, and we have a run of 6. So a rise is negative 12. Our run is 6, so we have a slope of negative 2. We have a y-intercept. If you look where it's going to cross the y-axis, it crosses at 0. So our equation of our line would be y equals negative 2x plus 0. Since you have a plus 0 out there, it's understood. So we can simply leave that as y equals negative 2x. And that's the relationship, and we can see that now. The relationship between our x's and our y's. Y value is equal to negative 2 times whatever the x value is. And it's the same thing here. 4 to negative 8, and 4 times negative 2 does give us negative 8. Now, another way, again, that we could solve this type problem is we need a slope and a y-intercept. So since we only have 2 points, what I would do first is I would actually find my slope. And given points, we know that we can find slope by using the slope formula, y2 minus y1 over x2 minus x1. And in this problem, keep in mind again, anytime you have a point, you have x's and y's. The second y minus the first y would be 12 minus negative 5. The second x minus the first x would be negative 4 minus negative 3. And again, anytime we have 2 minuses, we make it a plus. That would be 17 over negative 1 or negative 17. And now that we have found the slope, we only have one more step. We have to find the y-intercept. Now before, on the previous problems, we were given a slope, and we were given a single point. We weren't given 2. So, and then we took those 2 pieces of information, we plugged it into either point slope or our slope-intercept formula, Now here, which point do you use? That's entirely up to you. You can choose either point. I usually tend to use the one that has smaller numbers or that might have all positives. So I'm going to choose the point -3, -5. And I'm going to work this both ways, and you choose the way that you would rather work it. I'm going to first work it with point slope formula. Y minus y1 equals m times x minus x1, and I'm going to again choose the point -3, -5. So I now have y minus y1 equals m times x minus x1, which is -3. Anytime you have two negatives, make it a positive. We now have y plus 5 equals distributive property gives me -17x and -51. Move the positive 5 to the other side by doing -5. And I have a final equation of y equals -17x minus 56. This exact same value could be found by using slope-intercept. Step 1 will again always be find your slope. Step 2, you can use either of these methods. Looking at slope-intercept now though, pick either point, and since we picked this point for the first one, I'll pick this point for the second problem. Plug in your y value, plug in your m value, and plug in your x value. Clean it up, you have 12 is equal to 68 plus b. We subtract 68 from both sides, and we get that b is -56. And since I now know b is -56 and m is -17, I have the equation y equals -17x minus 56, which matches our answer from the first part of the problem. Okay, next up, let's talk about parallel and perpendicular lines. And let me remind you that anytime you have two lines that are parallel lines have the same slope. Anytime you have perpendicular lines have opposite reciprocal slopes. So keep that in mind as we're working through these problems, because this problem says find the equation line, and they give us a point. We want our line to pass through the point 2, -1, and we want it to be parallel to the line 9x minus 3y is 5. Again, it's very important to remember that parallel lines have the same slope. So the way we're going to work this is we're first going to try to find the slope of this line. Because we know that if we're looking for a line that's parallel to it, it has to have that same slope. So we take 9x minus 3y equals 5. And sometimes you won't have to go through the step. Sometimes this will be written in slope-intercept form, and you can simply look and see what the slope is. But in order to obtain the slope from this, I'm first going to move my 9x over. And that gives me -3y equals a -9x plus 5. I'm then going to remove my -3 since it's being multiplied by dividing. And I'm left with y equals -9 divided by -3 is 3. And a positive divided by negative is a negative. And since I cannot divide this, and since I cannot reduce it, I will leave it. So what I have now is I want my line to be parallel to this line. In order to be parallel, once again, they must have the same slope. So I know that my line, and this is not my line, this is the given line. My line must pass through the point 2, -1, and must have a slope of 3 in order to be parallel to the given line. And we see now what I want my line to look like looks just like the problems we just worked. We're given a point and we're given a slope, therefore let's obtain an equation. And I'm simply going to use y equals mx plus b, slope-intercept. So here we go. Let's plug in all of our information to obtain our b value. We know that my y value is -1. My m value is 3. My x value is 2. And I'm looking for b. So I have the equation -1 equals 6 plus b. When I subtract 6 from both sides, I get that b is -7. And since I know now that b is -7, that m is 3, that my line is y equals 3x minus 7. Again, notice y equals 3x minus 7 and y equals 3x minus 5/3 do have the same slope, so therefore they are parallel. And another way to check, I wanted my line to pass through the point 2, -1. If we plug 2 in for my x value, 3 times 2 is 6, 6 minus 7 does give me -1 for a y value. Okay, now let's work on to where we're looking for a perpendicular line. And I'm looking for a line that is perpendicular to 2x minus 4y equals 9. Reminder that perpendicular lines have opposite reciprocal slopes. I have the equation 2x minus 4y equals 9. I cannot identify the slope by simply looking. So first step, I'm going to take 2x, move it to the other side. I now have the equation -4y equals -2x plus 9. Next step, to get rid of -4, I'm dividing everything by -4 since it was multiplied times y. And I have y equals negative divided by negative. We're going to reduce this thing. Negative divided by negative is a positive. 2 divided by 4 will give us a decimal, so let's simply reduce this fraction. Divide the top and bottom by 2, you get 1/2. Positive divided by negative is a negative. We cannot reduce 9/4, so let's leave it. So their line is actually y equals 1/2 x minus 9/4. My line. I want my line to be perpendicular to the given line. The given line has a slope, a slope of positive 1/2, so my line will have a slope of -2/1, or simply -2. Because again, perpendicular lines have opposite reciprocal slopes. So my slope is -2, and I want it to pass through the point 5, 4. And since we did slope-intercept on the last one, we'll use point slope on this one. Y minus y1 equals m parentheses x minus x1. So we have y minus, our y value is 4, m is -2, and x minus our x value is 5. Cleaning up, we have y minus 4 equals -2x, and -2 times -5 is a positive 10. To remove our -4, we're coming to the other side and doing the opposite, which is plus 4. We have y equals -2x plus 14, which, if graphed, would pass through the point 5, 4. And if we look at the graph also, it would be perpendicular to this because they have opposite reciprocal slopes. Okay, our last problem, we're actually going to work a word problem here. But we're going to go about the same set of methods to work this word problem. It says, for a service call, Belmont Heating and Air Conditioning charges a $65 trip fee and an $80 per hour labor fee. Formulate a linear function for the total cost of the service call, where t is the length of the call in hours. Now let's think about method here as far as how would we figure a total cost for this function. And what I mean by that is, it says that $65 trip fee and $80 per hour labor. So you're going to have to pay $65 regardless of how many hours. When they come out, when they make the trip, it's going to cost you $65. While they're there, you're going to pay $80 for each hour. So let's look at this. If they're there for, let's just say 2 hours, you're going to pay the $65 trip fee, plus you're going to pay $80 twice because they were there for 2 hours, which would be a total of $225. If they were there for 3 hours, you would pay $65 plus $80 for the 3 hours, which is equal to 240, 65 would be $305. And you can keep doing this on, and you can try it for 4 hours, 5 hours. What I'm looking for is, what's the process that you use to find those answers? And I find out that, well, what if we don't know the hours? What if we let t be the number of hours? Well, I noticed that I'm always going to have to pay my $65. Plus, I'm always going to have to pay $80 for however many hours that they're there. 80 times 1, 80 times 2, 80 times 3. So here we have a general function, whether t be 1, 2, 3, or 20. No matter what we plug in, this is the process that we always follow. So therefore, a function, the cost, and the cost is a function of t, c of t. The t in parentheses, same as f of x that we've been talking about with a linear function. The t in parentheses simply means that is your independent variable. That's your plug-in value. That's what you plug in to obtain the cost here. So the cost, which is a function of time, is equal to, and I'm going to do something else with this. I'm going to actually reverse it and write that as 80t plus 65. That way it looks more like the linear functions we've been working with. And we see here actually that 80 is our slope. And we're going to learn that slope is very close, actually slope is always a rate. It's a rate of change. Whatever your rate is, and in this case your rate is $80 per hour. Whatever that rate is always what's going to be connected to that variable is always going to be your slope. Okay, on B part we're actually asked to graph this model. And notice here they've only given us the first quadrant because, well, number one, our time can't be negative, and the cost is not going to be negative either. So therefore, we're only concerned about graphing this in the first quadrant. And the way that we're going to graph it is you got to be careful. It's going to be hard to use our slope with this model the way it's set up because the way the domain is set up, that's fine, but our range, it's going to be hard to rise 80 and run 1. So it's going to be a little bit harder to actually use slope-intercept to graph this. So let's do it like this. Let's just put some values. Let's get us some points that are on this graph by plugging in some values. We've actually already done that up in the top right-hand corner here. But for a cost for a time of 0, if t were 0, if they don't spend any time there but they do drive out, you do have an initial cost of $65. Halfway up would be 50, so I'm going to go up slightly further than 50. This is not an exact science. Just get close with these graphs. If they spend 1 hour there, you can plug this in. You're going to pay right at $145 for 1 hour. So go over to 1, go up to about 145. We've already calculated 2 hours is going to spend about $225. 3 hours is going to spend slightly over $300 at $305. And we see that we could actually connect your dots here. And we do have a graph, a linear graph of this function. Okay, part C asks us to use the previous model to determine the cost of a 2.5, excuse me, erase that, of a 2.5 hour service call. And here's the thing, we can use our graph here. We can go over, okay, how much will a 2.5 hour service call cost? We can go over to 2.5 here and go up to our graph, and we can get an estimate from the graph. And I would say the estimate would be somewhere around $275, $280 right here. But now our best bet is going to be to use this model. If we want to know how much it's going to cost for a 2.5 or a 2.5 hour service call, the best method is going to be to plug it into this function. Y equals 80 times t plus 65. So let's take out our time and let's put in 2.5 hours. So we know we're going to pay $80 for each of those 2.5 hours. So we multiply 80 times 2.5 on our calculator and we get 200. Plus we have a $65 service fee, which gives us a total of $265 is going to be the cost of our call, or the cost of this trip, 2.5 hour service trip, which is where we see is on our graph. But again, it was hard to estimate, or it's hard to get an accurate answer when you're simply using a graph.